Hello viewers, in today's session we are going to discuss another important problem from integration, and in this class we are going to evaluate this important integral where we have 0 to a dx over square root of ax minus x square, right? So in this class we'll solve this integral with the help of the concept of beta and gamma functions, right? And before applying the concept of beta and gamma functions, let us first apply the method of substitution. So let us first take this integral as I, right? Now see, we can also write this integral as square root of x times a minus x. So taking x common from ax and x square, we can now write square root of x times a minus x. So let us further write it as dx over square root of x times square root of a minus x, right? Okay, now we can write 0 to a, and here we have dx, and here square root of x can be written as x raised to half, and here we can write a minus x raised to half, right? Okay, now let us make the substitution, that is x is equal to a times t, right? So that t is equal to x over a. So let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of at, and a is a constant. So we have a times the derivative of t with respect to t, that is a times 1, that is a. So we can now write dx is equal to a times dt. Okay, now here the limits of integration vary from 0 to a. So when x is equal to 0, which is the lower limit, the value of t can be obtained from this relation. So we have t is equal to 0 over a, that is 0, and when x is equal to a, then t is equal to a over a, that is 1, right? So now we can write this integral I as t is equal to 0 to 1, because when x varies from 0 to a, t varies from 0 to 1. And here for dx we can now write a dt, and here for x we can write at. So we have at raised to half, and here we have a minus at raised to half, right? So let us now simplify the integrand here. So we can now write 0 to 1. Here we have a dt, and from here we have a raised to half, then we have t raised to half, and from here we can take a common. So we have a raised to half times 1 minus t raised to half, right? Okay, so now we have 0 to 1. Here we have a dt, and here we have a raised to half and a raised to half. So this is a raised to half plus half, that is a raised to 1, that is a. So here we have a, and here we have t raised to half times 1 minus t raised to half. So now we can cancel this a and this a. So we are now left with 0 to 1, and here we have dt over t raised to half and 1 minus t raised to half, right? Now let us take both these terms to the numerator. So we can now write I is equal to integral 0 to 1, and we have t raised to minus half, and here we have 1 minus t raised to minus half and dt, right? Okay, now let us convert this integral into the beta function, which is also known as Euler's integral of first kind. So we can now write t raised to minus half as half minus 1, because half minus 1 is minus half. And here also we can write minus half as half minus 1, and here we have dt, right? So now we can see that this integral is similar to our beta function, that is beta m comma n is given by a 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. And this integral is similar to this one. So if we compare both these integrals, then the value of m is half and the value of n is also equal to half. So this integral I is now equal to the beta function, that is beta half comma half. So now we have to find out the value of this expression, that is the beta function, using the relation between beta function and gamma function. So now the beta function and gamma function are related by this expression, that is gamma m, then we have gamma n divided by gamma m plus n. So here I is equal to beta half comma half. So we have now from this relation gamma half, then we have gamma half, and then we have gamma half plus half. So now the value of gamma half is square root of pi. So here we have square root of pi, here also we have square root of pi, and here we have gamma 1. Half plus half is 1, and the value of gamma 1 is equal to 1. So here root pi times root pi is pi, and gamma 1 is equal to 1, so this is equal to pi. So the value of this integral I is equal to pi.